Is there such thing as the modern data stack? Now, we're tempted to draw a block diagram of the last system we built and think, yep, this is the one. This is all the technologies everybody should be using. Everybody Control C, Control V, and it'll be great. I'm not sure that's right. And I talked to Peter Corless today. He's a product marketer at StarTree who is a deep thinker about this kind of thing. And he's got the suggestion that maybe stack is the wrong way of thinking. Maybe ecosystem language that we're so fond of is not quite right. And maybe the idea of federation is where we need to go next. So let's listen into Peter's thoughts on today's episode of the Real-Time Analytics Podcast. Hello and welcome to another episode of the Real-Time Analytics Podcast. I'm your host, Tim Berglund, and I'm joined today by my friend and coworker, Peter Corless. Peter is a product marketer at StarTree, and I think beyond that, a deep thinker about a lot of things. Peter, welcome to the show.
Thanks very much for having me. Yeah, so I think that we're at a kind of a real turning point in the industry where we've gotten a lot of headway, but we don't even know where we're plowing towards.
That feels very true.
We know
one could take this in a number of directions. I know you have a particular one. What is that? What is that direction?
So I think that when we've gotten into the cloud native era, it was based on an impetus, a momentum from everything we had learned up until that point. And so we've inherited a lot of terminology, we've inherited a lot of technology, and we've assembled it. We've cobbled together these gigantic aircraft carrier shaped systems of data. And they're not all the same. And the language that we use still holds us to some of the expectations and mindset of those former platforms. And talking with some technologists at last Real-Time Analytics Summit, talking with people throughout the year, I've really noticed that there's kind of an emerging model that's coming, but we don't even have the language or the grammar to describe what the new data architecture is going to look like yet.
And I think this is a thing that happens a lot. It happens in technology. It happens anytime there is kind of the ground underneath you is shifting. You've got a way of thinking about things, and you've learned that, and it has been a serviceable and good way. But those artifacts, I use the phrase artifact thinking,
right.
They stick with you, and
exactly.
You're using them even though, you had adapted them for Arctic tundra, but you're now in a mid-latitude deciduous forest, and how did that happen?
Exactly.
Yeah.
Exactly.
So biasing the conversation with some ecosystem terminology. Maybe we'll get to that later, but go on.
Yeah. And I think that one of the big words that I keep hearing used, which is very much a 1990s to mid-millennium term, is the concept of a stack.
Yeah. What's a stack? I know how to use the word, but if some smart layperson just stopped me and said, what's a stack?
So if we go back to the origin of a stack, it was all the things running in a 1U box in a data center that would all be running in the same system. So it might be Linux underneath. It might have an Apache web server. It might have MySQL, and it probably had some form of scripting, whether Perl or PHP or Python, whatever. Right? That was the LAMP stack.
LAMP. I was going to say that might be. Well, it's the first time I can recall that phrase, being used. LAMP stack, right?
Exactly. Very 1998. It was a wonderful thing at the time because
so much of the internet was built on that. I held it. Frankly, I have to confess, I held it with contempt because it was PHP, and I am a good programmer, and I would never, and that kind of thinking is, of course, deeply immature, and it was a thing that worked very well.
Exactly. And I cut my teeth on CGI bin scripts and Perl, right? So we don't do things that way anymore. And just like we had to give up CGI bin, we have to now give up, like, for instance, the LAMP stack eventually seeded way to what was known as the Jam stack. And that was JavaScript, APIs, and markup. And that's 2015. So already we're seeing that's practically 2 decades later. But notice what happens with the Jamstack. The Jamstack doesn't care what operating system you're working on. It just doesn't care because it's just accessing things through an API.
Right. And to a large extent, it was an attempt to get everything out of the database that could be gotten out of the database. You wanted not to use databases for every piece of content, every page load. That's just not what websites are. So sprinkle some APIs in there for the live parts. And which is kind of a different thing, but it's still a stack, kind of.
It's still a stack, sort of. It's more of a meta stack because you could point to a Linux. Right? But can you point to APIs? Like an API is this very loosey sort of, amorphous layer. It could be Stripe. It could be a call to a database on the back end through a microservice. But what is an API? Oh, it can be anything, right?
Sure.
And the Jamstack was more of a meta stack than it was more of a. See, like I'm old enough to remember when I first came to Silicon Valley, the stack we were talking about was a 7-layer cake of the OSI model.
There you go.
Right.
We'll include a link in the show notes.
Right. But the 7-layer cake, the original stack was just a networking stack. It wasn't even an application stack, right? It was just how do you get out of the NIC onto the internet?
Right.
And I think that's one of the things we also have to take a look at too is from Jamstack to Lambstack to OSI model, what problem is the stack trying to solve for? And in many cases, it's not a comprehensive end-to-end architecture. It really is often just a slice of an overall data architecture. Okay.
The stack. So now when you're saying stack, do you mean people say, maybe this trend is dying, but has been a popular conference talk. Here's the modern data stack. Right. Somebody will get up and say, this is the modern data stack. There's a block diagram. There's a number of technologies. Here's how you do things. And often it's, here's the system I built at Corp that got me promoted to principal. And it was a good thing. I mean, it's not like, this is not smoke and mirrors. This is a system that worked, that delivered results for a business and everything. But it's that modern data stack. It seems like there are an awful lot of the modern data stack. Like standards. The good thing about them is there are so many of them.
And the interesting thing about what a lot of people consider a modern data stack is that it's usually a middle-endian piece. Like, let's say, I'm going to just talk about my friend Tim Spahn, because this is where a lot of this discussion came from. He talks about NiFi and Kafka and Flink as a stack.
Okay.
Right? But that's a middle-endian pipeline, right? It's not talking about where the data came from, and it's not talking about where the data is going to. It's a complex, very fast middleware.
Yes.
And so when we talk about modern data architectures, from where the sources are, your gazintas, and where the data is going to, your gazatas. Like,
I would want that if there were this model that I was supposed to build systems on. I'd want the gazinta, the gazata, and the stuff in between that does the things I need. Which, to your point, is going to be kind of bristling with APIs, so I can talk to all that stuff in between. But yeah, that's what I expect.
Yes, and so these days there's a kind of a meta pattern that most data architects have. It includes one or more OLTP-ish type systems, and those OLTP-ish type systems are being fed from something upstream to them, whether mobile devices or IoT devices. There's something feeding the OLTP systems.
There are phenomena in the world.
Right.
Yeah.
And then that data has to go through some form of corporate governance, change data capture. It has to then go through some sort of stream processing. And then eventually it goes somewhere. And in the middle of that, there might be decorations and annotations. There might be sideband conversations or aggregations and combinations and all sorts of transformations. And then eventually it goes somewhere else to then be analyzed, because a long time ago, we realized that you don't want to saddle analytics on your production system.
Right. There are physical reasons, mathematical reasons for, the way caches work. That just doesn't
Right. The historical reason why you separated the data warehouse from the mainframe.
Yeah.
Right.
Yeah.
You did not. You did not want to make people booking tickets on your airline more difficult than it already was.
If such a thing were possible.
And so, but the word ecosystem to describe this has been used over and over again. We always talk about data ecosystems.
And I do for data and for compute. I am guilty of using organic ecosystem language
Mhm.
and everything to describe those, and I think there's something to that. But I have always been aware of perhaps a bit of hypocrisy in that analogy, and I wonder. Go on. I wonder where you're going with this.
So the hypocrisy is that it is organic, that it grows naturally, that it spontaneously generates data or connections between each other. It grows like vines. These systems don't interconnect naturally. They have to be made to interconnect. This is all inorganic chemistry. You are forcing bonds between systems.
Yeah. Or more to the point, designing explicitly
Yes.
every piece. And
Yes.
if your view of ecosystems is that they are undesigned, then, well, that's a bad analogy.
Exactly.
And
Exactly.
I don't want to throw shade on like my friend Neil Ford and Mark Richards. Friends Neil Ford and Mark Richards have a bunch of material on what they call evolutionary architecture.
Right.
It's a thing. It's an important set of disciplines and ideas. And frankly, I think it ties in a lot to what we do in the event-driven world. It's not nonsense. It just we kind of have to footnote it, like you're saying. Everybody's trying real hard to build things that don't build themselves.
No, but it is a recognition of the fact that the Glasshouse team, the data platform team, is not the only vote in an organization anymore. You now have department heads that say, hey, I just got a new data source. You need to integrate it. It's no longer the days when IT controlled what got onto the internal computer ecosystem, right?
Okay, because
So in that way, it is semi-organic in the sense that you need to deal with these emergent data flows.
and that I think is what redeems that kind of language and that kind of thinking is that looking at it from the top, it sure looks that way. And
Right.
we'd actually kind of like that. I think, I think that's one of the promises of the event-driven world is that it gives small teams now the ability to, if I may use the term, intelligently design, carefully craft things for their own localized needs. And looking at it from the top, you're not really centrally orchestrating anything, and stuff just kind of happens. But
In theory,
the
that
just
would be,
happens is still hard work.
yeah, exactly. And that's the thing, is that it's not like a person can go to a natural language processor and say, find me all of this data, find me all of the customers that really want to buy, my pink shoelaces, right?
Yeah.
You have to then go to any number of data teams to say, well, where do pink shoelaces live in this company? You might have to talk to the priests of SQL, right, to make an incantation, a magical incantation, and hand you the package of a scroll of pink shoelaces, right? And it's not as transparent, like it's not a democratization as we would have imagined, like with other things. The word processor, for instance, allowed anybody who is a reasonable office worker to write up something, and then email allowed it to be sent to somebody.
Right.
Data these days is still very much artificially barriered to the rest of the organization for many good reasons, right? You can't allow unbounded queries across very expensive data systems. But so you have the platform teams building these aircraft carrier systems, and you still have a disjunction between that and the business tools and the dashboards and all the rest of it. There is this, and again, that's where you have to have very big brain people, maybe data scientists, data engineers that know how to get this data and present it in a knowledgeable format, for a knowledge worker. And I think that that's the other thing too, when we talk about these ecosystems. You would think that anybody would be able to tap into this, but it's not like fresh water. It's very much like you're setting up wells and pumps to get it to people's houses.
Got it.
Yes.
That maybe I should interrupt you. Sounds like you're
Oh no,
you are taking this where you're going. Yeah.
I can rant on this all day. Trust me. But if you have a question, go ahead.
No, I don't. I want to hear where the rant goes next. This is important.
So when I came here to the Silicon Valley in the 1980s, it was the world of IETF draft standards. It was the world of modem standards, even at the time, right?
Yes.
And these things were controlled by international standards bodies, right?
Yes,
the IETF. Yeah. And there was RFCs. And then when the web came along, we had W3C standards. But the world of big data is not governed in the same way. Other than the ISO and SQL, when we talk about open standards, for instance, right now, just for data tables and data warehouses, there's 3 separate competing open table standards.
Yes. And a fourth that recently crossed my radar. I'm not going to be able to remember it, but yes.
And so when we talk about making these open data architectures, they're not open. They're heavily biased towards specific vendors. They're heavily biased towards cloud vendors and their ecosystems. And so when we talk about connecting these systems, it's like Kafka is the closest thing we have to kind of like the Swiss Army knife for real-time data.
Yeah, or lingua franca is almost the wrong analogy, but it's kind of that. It's the universal docking port that all the spaceships have. You just hit the nail
on the head. Lingua franca, by the way, is an Italian term for the French.
Yes.
Which we use in English.
Yes. Amazing.
And I think that that's an example of, we don't really have open standards the way we've had in decades past. We can't rely upon a W3C or an IETF to really help us govern how we're going to have these gigantic data systems talk with each other. There are de facto standards, and like Kafka is the closest one that we have to like this, corporate enterprise middleware, right? Yeah. But beyond that, then, for instance, we have SQL, but SQL.
I was going to say that's kind of a standard, but are you going to say how do you get it and how do you get things back? All of that is, the wire protocol. Is it Correct. JSON? That's all up for grabs depending on the database.
And even if you take a look at like how null is handled, is different depending upon which flavor of SQL you're talking about.
Absolutely true. Yes.
Yes. So we talk about SQL as if it's a monolithic Catholic church, a universal kind of language, but it has its own dialects. It has its own denominations within SQL.
Yes, and its own semantics. That is an more interesting problem when you get into transaction isolation, for example. In transactional databases, you've got the 4 isolation levels, completely different semantics between implementations.
Correct.
And that's very, very interesting, fun stuff to dig into. But there's a standard, and then there's the real world, and not everything is what the standard says.
Exactly. And so years ago, believing that everything was going to be SQL, and of course today we know that not everything is even SQL, but let's pretend that everything, at least in a context, is SQL.
Fair amount of it is, but yeah, I'm willing to play along.
We'll play, right? And so what happened is that various database vendors said, well, why don't we create a way to do federated queries? We'll send the same SQL or the equivalent SQL query across all the different SQL databases that might be running at a company.
Okay.
All right.
So like my application Postgres's and my Hive or Spark SQL, depending on what year it is, and my Pinot and all of these things, all these different places where there's data, I can send a SQL query that is maybe, probably not, exactly the same string, and certainly different wire protocols. But this query federation layer negotiates the wire protocols and the probably not of the SQL dialects.
Right. Now, let's take a look at a couple of things. So first of all, we talked about the dialect of SQL, but how about performance? What if one database returns results within a 30-second timeout window, another one's going to be chunking along for 15?
Yep, realistic.
A very realistic thing. So what do you do in terms of marshaling results? So federated queries don't solve all issues, especially when you have these impedance mismatches across different systems.
Okay.
So it's a thing, but there's a reason why we aren't talking about federated query systems all that often.
I mean, we're not. We, in fact, just recently had a podcast episode. I'll link it in the show notes on Trino. Sorry,
Right.
not Trino. Yeah, right. Starburst.
Sure. Very
so,
popular. Yes.
Common query federation thing that shows up in this so-called modern data stack an awful lot. But I think what you're saying here is that this idea of there being a modern data stack is just not quite true.
There's different attempts, but notice how the big, Dukem battles right now are just the table formats, not even getting to a common query structure across all these different systems. They're still just arguing about the table format. So yeah. we're still a couple of steps away from being able to go from a common table format to a common query model across all of them.
Right.
I mean, some use Spark and others use SQL. And I'm sure that there's probably a meta way of doing Spark queries and SQL queries, but it's again, you have to make these translation layers. In the OLTP world, you have GraphQL, where companies are desperate to not have to write specific SQL for the specific dialect. They're trying to come up with a GraphQL meta layer to say, right, here's your API, but it's a lowest common denominator for many cases.
Yeah. And one that, I mean, has seen a lot of adoption. I'm not sure from a standards perspective, here's a good way to lose subscribers, that GraphQL was the right idea, but certainly one that has seen adoption and has utility and is a thing that you're going to use to talk to right, transactional systems.
And I think that that's a great example of, do we try and create LCDs, lowest common denominator standards, or do we try and optimize for specific use cases, right? Not everything is a data warehouse. And there are obviously very big invested people that try and say, well, everything should live in your data warehouse.
Yeah.
But anybody who needs to run in real-time analytics knows that, no, you don't even want to go there. You really want to stay outside.
That's actually just not going to work. So tell me where you think we ought to go. Is federation the answer then? If the one stack to rule them all and, no, wait, just listen, this is really the right answer isn't really the right answer. Is it just kind of build systems that you need in each place and link them? Is that?
I love the word federation, right? I've always been a Star Trek fan. So I love the concept of the federation. And if you take a look at Star Trek, you have Vulcans and you have humans and Andorans, and Klingons. They're all in the federation. This is not a homogeneous one people federation, right? It's a cosmopolitan system.
Yeah, where every planet kind of seemingly does its own thing. Maybe the Federation is responsible for what we might call foreign policy. It's kind of space NATO.
Right. And so we might need a federated data governance, right? So all systems in your enterprise, to use the term, may have a common way of accessing different decks, et cetera. They all need to have common functionalities. There's a transporter room. There's a bridge, right? And so I think what we're seeing in a federated data system is common functions. Again, there has to be a transporter system. There has to be a way to get data from point A to point B, right? Uh-huh. There's these warp cores that make us go really fast. There's bridges where we can command from. And I think that right now there's no standard around what a federated data system looks like, but there's a kind of a meta model that we all hold in common. Like all of us go like, yeah, that sounds really familiar. But again, I think that we're lacking protocols and standards to create these, where basically there might be there, if you take a look at DB engines, there's over 400 databases to choose from. And you might choose maybe 3 or 5 or 10 different databases for different specific point functions in your organization. But they all somehow need to be governed similarly. They all need to be able to be have their data products made available to the organization in a common method. And that's the standards I think that we lack as an industry. How do we advertise data products? How do we change them over time? Anybody who's running a production system knows how difficult schema management alone is.
Yes. It's been clear to me, and in the event-driven world, it's been clear to me for 5 years or so that's the pain point. If you talk to folks doing Kafka at scale and really, allowing their architectures to readapt to events as the central phenomenon of the system. Schema is the problem there. But there's no real consensus. Okay, so I think what you're saying is, I think it feels like this is going to require a part 2. So, listeners, it's possible. Peter and I are going to talk. We might do a part 2 here because I think I really clearly understand the problem as you've articulated it. We had this idea of a stack, and it was good for where we were and things we were building, and now we're kind of in a different place, different scale, different problems. Stack doesn't seem to be working, and we try to use ecosystem metaphors, and there's something there, but it's not quite clear that that's right. And this idea of federation, you've laid out the problems of federation. So we'll talk see if we can get a vision.
Sure. And
in a future episode of what that would look like.
I invite other people to contact me if they have their own visions of what a federated system looks like. I'm just going to point out one example of an orthogonal point from the federated query system of the database world. Federated learning in AI ML says, don't move the data. Let the data be where the data is. For instance, there's federated learning in every one of your smartphones. And your local typing is stored locally, but there's a machine learning algorithm that's being run by the big companies that make these kind of mobile devices that want to understand, what did you do autocorrect on? And what did you say? Oh, no, that's wrong. This is the way you spell that word. So you don't move the data from your smartphone to a central repository for analysis. You do the learning locally, and you just ship the kind of process model back to then be combined with all the other results that have come up from these cell phones. And that's a thing called federated learning in AI ML. And that's called horizontal federated learning. And there's other kinds of federated learning as well, where you don't ship the data. You leave the data where it is, but you ship the learning back. And see, so when we talk about federations, there's very different orthogonal models, like for edge devices to core central functions of an enterprise. And so when we think about this, we really have to open our minds to what will the systems we're building for the 2030s and 2040s look like?
I'm going to put a link in the show notes to StarTree Community Slack, where people can most easily find you. And I'll have, of course, your name will be in the episode title, Peter Corless. Find this guy. I think this is a conversation that has a lot of promise. I want to talk about it some more in a future episode of the podcast. I love the way you framed this problem. And I would like to conclude by saying that my guest today has been Peter Corless. Peter, thanks for being a part of the Real-Time Analytics Podcast.
Thanks for having me.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.